guys, good morning. Actually, yeah, still morning by 1 minute. Alright, can you guys hear me? Just put up on the chat. Hope so. Yes, okay, great. Thank you very much. Make sure my audio is for the yes, okay, great. Right, morning, or afternoon, yes, afternoon. Look at the attendance here. Alright, so today what we're looking at, Lab 7.1 IPv6 inter-VLAN router. It's, as you can see, it's going to be an advanced lab. Let me just skip ahead and you'll see it. Right, so main steps: enable IPv6 unicast router in R1, create and configure subunits in R1. You're going to add IPv6 addresses. You're going to have clients correct gateway addresses, add management VLANs, switch, configure IPv6 management, and testing in between networks. So that's main steps. Now, so because it's we go forward, right? The solution, the command file and solutions are available, and I will show you that just now. So you can actually configure without command guidance, as in me running through the lab, or you have the step-by-step commands to perform. So what you're going to do is, for those who don't want to do it on their own, just follow me. I'll be running through this lab, right? So we start from the beginning. Right, so this is what our IPv6 lab is. Now, inter-VLAN routing and other advanced labs would contain a diagram like this, but now we're focused on IPv6 and VLAN now. The device in question that does most of the configuration, where we do everything, will be in R1, in the middle here. So this one little R1 device is going to do routing between all these different networks that we have created. Interesting enough, let me see, these networks are named, yes. So our shadow is here, which should have been renamed to research. Shadow network here should have been a research network now. We have accounts. You have server network. Accounts is here as well. This should, yeah, server network. I think something off with the screenshot. If you open the packet tracer, these two, supposed to be two different color blocks, green and pink. Right, so if I open the packet tracer, oh yeah, that's why I end up doing it. The blocks are difficult in packet tracer as well. So I end up just label it here that these two devices are basically on the different network and the VLANs as well. Right, management network is VLAN 3. You'll notice one thing with the management network, and you're not seeing it specifically to anything here. Let me zoom out a bit. Right, it's not specific to any PC or any block at this point. The management and network is actually for the management of the switches. So it's kind of like and that's why you have to start thinking VLANs now, not as physical separations, now more logical separations. Because this doesn't belong to any specific location. It actually is on every single switch is going to have a management VLAN to manage that. So that's where you have to start to abstract out and say, okay, it doesn't belong to any specific diagram, and that's where it's labeled there separately. Skip ahead. Right. All these, again, IP address tables, same what I expect from the assignment. The Marcus has it now, so he's going to work on it. In addition to that, we're going to, for your group project, I expect something like this. Now, luckily for you, group project would not ask for IPv6 at this time, so you don't have to fill that piece, which is unicast and link local, right? What you're looking at is the IPv4 address, so you expect tables for your device as they're growing up, building. For those who haven't started a group project, you should really start with kind of like this first. Get your tables out, map your devices. Then you start to put in your block IP addresses and stuff in there. So you kind of have it to fill in. I mean, some people say, oh, let's look at a diagram first and then figure out how to know. You could do that, yes. And you can say, yes, I've signed that IP block here, I signed that IP block here. While it's doing that, you can have your table. So, and you'll notice VLAN numbers up here, VLAN. Right, VLAN 81, 111, 11, 5, and it's supposed to have 3 here. As you can see, VLAN 3 setup. Now you'll notice one thing. There is no, the interface, in this case, it's not an actual GI. So yes, you can set up a VLAN as interface. So remember I told you it's not attached to any physical, in most cases not attached to any physical port per se on the network in the design, because it's going to be logical. So you can actually create a VLAN tree, an interface VLAN tree, and actually you can actually put an IP address on it. Right, so that's how you set it up. So we create an interface on the switch called the interface VLAN tree, and we'll see it later on. Add an IP address, and once that trunk is allowing VLAN tree across, that traffic or broadcast traffic for that VLAN tree, which is including all these IPs we're setting up here, right? All these IPs will be broadcasted across that VLAN tree. So the next thing is you'll ask yourself, okay, well, we have the logical network of VLAN tree. How do we bring that into the physical world? Because if you want to have your PC to connect to it and stuff like that, you just basically take a port that is an access port, that is where the switch can see VLAN tree, and you put that access port onto VLAN tree. Switch for mode access, switch for VLAN tree, right? And once that happens, device connecting there, you set them to the right IP in the subnet, and that PC or device can then communicate with all these switches on that VLAN. So you kind of map out a logical network, in this case a VLAN, into the physical world, if you want to call it that, and you can then interface into those logical networks. So you can literally have a whole lot of communication happening logically and never reach into the physical. And that same thing with virtual switches, virtual Ethernet, virtual SANs, all those things are happening inside systems, and you don't really see it happening in the real world unless it have to interface with a physical component. So a virtual SAN is logically set up, but it does have to integrate with disks below. So not virtual disk, it's actual physical disk it's going to deal with. So virtual SAN is going to set up like that. SAN is storage area network, so that's what it means for storage data. While you have virtual net VLANs or virtual LANs. So just as a little background, then of course you have the usual Blackwell VLAN, pruned from any port, and you guys have done this in the assignment. Any other VLAN can be used. So I'm going to put a 999, and I actually, we had the link there as well as before. You could read more about it, and they use it, and I'm going to use it as well. Some Cisco techs use 99 as well, but 99 is kind of like, depending on the network, like our campus, we have over 150 VLANs, so 99 is kind of like part of that, so we wouldn't want to put it there. That's why we put that all the way up to the end. Right, so it's normal. Rename your packet tracer file, download and rename. And I'm going to just follow these steps. You guys follow me and follow what I do on the screen, because I'm actually going to just go through these steps one by one and tick off and go along, right? And not only that, so remember I said they're config files, so I'm going to use that too. Right, so you would have seen some command files I had. Let me launch them up. Let's see if this will work.
That's me.
Yeah. We created a separate. Right, good.
I think they.
Just bear with me a few minutes on the. I have 4. Yeah, I only have like switch 11 and 12 running config. But these two guys, I didn't have 21, 22. I'll generate that and I can always put up online when I finish. Right, so the text file I would have put it online on my LAN as well. So as I say, the main steps. Router 1, we'll focus on router 1. And this is the configuration of router 1. So I can actually literally follow this configuration router 1, and this is steps 1 too, because we have sub interfaces being configured. And it's actually putting in IP addresses on the different networks and the VLANs. This is everything, right? All the configs. Switch 11, 12, 13, 21, 22. Yes, core is there. And core 1, right? So this command file is supposed to technically contain all the commands I'll be using for this lab. Right? This is what I expected from you guys from the assignment. I mean, I had command files before for previous labs, but this is what I expect. That when you create it, you will have a command file where you have everything here. Now, I prefer Notepad, but when you copy paste into the project report, you just copy the whole block, paste into the appendix, and you could change the format and remove all the extra paragraph breaks and all that stuff so it'll be compact, right? I could just copy paste that back into a text file. Only caveats, it's the quotes. I'm not seeing any quotations here, so if there are any quotations in a Word document, sometimes it turns the regular quotes into like smart quotes, which is a different character format. So when you try to use it in a system, it will throw out errors. Same thing with copy pasting code from Word and put it into a command line and then trying to execute with quotes, it could cause trouble. So that's the only issue with Word to text file to Word kind of thing, how it deals with it. In addition to that, I dumped some running configs. Right, so and I did a few, so there's only like 1 or 3 running configs here. You guys can do the running configs later on if you want. So I dumped the running configs just for you to see what it looks like as a text file. A lot of these things you don't really need to add and enter back into the equipment. Me personally, and that's when I configure equipment. So this is a running config before it does any configuration, right? So we're going to do a show run config after. And we can create a text file and show running R1 running config finished, completed, right? And I'll show you, you can see the difference. Now that's 1. 2, with running configs, it's great. We do backups of that on our campus network. We back up running configs. So it's easier to just apply back to running config on equipment. That's how it works. For me, personally, that's my backup. What I would rather do is to create a config steps for my equipment and only make the changes that I want for that equipment and build it for that specific equipment. So switch 12, this is all the configuration required for switch 12. Running configs or not. So if the switch is out of the box, and the subpaths and all that would be in my steps here. Right? Now this case doesn't have it, but for this lab it is. Just this alone. So for switch 12, I'm just pushing this out into the equipment and configure. In campus network, we have much more configurations to put per equipment, but and I will have a recorded file for each of those. Compared to, and then I will have a backup running config. So I have both what is I can enter as an IT engineer, as well as what the equipment is showing me that it has in state, right? So I keep both because if you need to make any fixes or changes, you can go back to the original file here, or you go back to the running config and make the changes. Right, so that's me, that's my operation, how I operate. You don't have to do that, but when you could follow. Okay, so let's get into the router. Alright, go ahead, click. I'm hoping that we can finish this lab early. I don't think so, given that it's an advanced lab kind of thing. But we will see. Right. So basically, you can unicast routing, IPv6 unicast router, and then you start to create config interfaces, and then you add IP addresses. So we have 1, 2, and 3 steps. 3 steps are going to basically do everything on the router 1. Most cases, I will try to focus on getting all the components done on that device, and then move on to the other device. Sometimes, based on what it is a learning style, you will want to learn a specific technology, you'll want to do it for all devices, like VLANs. You add in VLANs, you'll add it to all the switches. Even though you haven't step management IPs and all those things, you will just add the VLANs. But my focus is that I'm going per device. When you do the RIP labs, which will be next week, RIP labs, we will actually do configurations, perform configurations on one device at a time, as opposed to going to every single device at a time. It just saves on time and back and forth. So that's why it's always good to plan ahead. So consider this configuration file I have as a planning ahead of what I'm going to do. Yeah. Sorry? Coursework is?
Exam.
Oh yeah, sorry, course exam is a Saturday, so RIP lab will be next Saturday, right? So yeah, not next week lab. Next week is the Saturday coming is not the Saturday, next week Saturday. It's going to be coursework exam, right? Is the lab after time after that. Right, so let's start. Configure terminal. So basically what you're seeing here on this config file, this is, you can take this and actually continue with it out. But you could follow what I'm doing here, I'll give my explanations. So you're going to do IPv6, question mark, a lot of stuff here, but we're looking at unicast routing, and it enables here. I think it cleaned out. Right. We're going to do sub-interfaces, I'm going to explain that just now. Some more modern equipment these days, there's no need for doing IPv-cast, unicast routing, or because the equipment will already, or if it switches, it mightn't allow it, but it'll already have IPv6 enabled already. So this is one step. Cisco may cover this still for IPv6, but it could vary. We'll always keep it in mind. So if you type in and it shows an error, say like on a router, and say it can't do it, well, at least you type the command. What you could do is to see if it can handle IPv6 commands, right? So typically, if it do IPv6 and you press question mark and it has commands in here, that means there's a chance that it's going to do IPv6 statements, right? So the next step, we're going to do interface. So what we're doing here, and I could, what I'm doing here, I'm removing IPv6 addresses on the interface itself. Why? Because we're going to do sub-interfaces. For those who have looked at my, hopefully you see my video. So I did not do inter-VLAN routing in the lab itself last week because I didn't have enough time, but I gave you a video I did from last year, previous year, on inter-VLAN routing. Alright, it's the whole lab, but I told you start from this part, so it's about half an hour to deal with it. And it deals with sub-interfaces. Now the thing with sub-interfaces is that you work is more like, sub-interface is more like your virtual interfaces, and then it kind of maps out into the real world on the actual link. Because of that, it works with tagging, so it's a sub-interface where you do tagging of the VLAN traffic, and it works together with that. That's one. That's two. If you put an actual IPv address on that interface, it can work, but the problem is that you don't want to you don't want that interface conflict happening, because you shouldn't have any IP addresses happening on that what you call it, the default interface. Right, so let's right, so we have the interface gig. We're gonna put no IPv6 address. And what I like about this, I'm gonna just literally copy and paste this into the interface. I'm not even gonna worry about typing and question mark. So that's why I like about the command file. So I can actually copy paste what I want. So there it is, no IPv6 address, no errors here. So it removed it. Now, somebody asks, okay, can I put like any IPv6 address statement in here? Yes, you can do that. Right, so I can change this up and put something else. I can put maybe 3000. And it'll still work because even if no matter what IP address it puts there, it just puts something valid. So in this case, I'm putting something that could have been valid, and we're just going to remove it just in case. So I think I can even go all the way down to like even double colon, even this. Right? If this is valid, it'll remove the IP. All I just need to do is just remove the IPv6 address. Right? Now the cool thing about this command file, look what I'm going to happen. I'm going to actually copy, give it the two commands here. So these are two commands. I'm actually going to paste this, and look what's happening. It's supposed to go to the second interface, gig 01, and actually apply the IPv6, no IPv6 command there. So I would have done that. Now you may ask yourself, okay, well, did it actually execute properly? Well, one way to tell, remember how we could tell? You could do a description, right? Right, gig 1, who is this? Gig 01? Right. We're going to do a DSC description. I'm going to put in a description in the interface. And what we're going to do is going to do show. Now this is a router, so its interface status may or may not show, right? Alright, so I'm going to break that out, right? No, this is doing show interface. Right, unfortunately it's not showing it, it's not going to show it here because it's remember this is dealing with router layer 3. Alright, I wouldn't go into much. Let's check it out, see if it comes up in regular interfaces. Right, gig 00, 01 is up. Right, so you could do show interfaces and you see it. This description, gig 01. Remember the one we had was gig 00? This gig 00 up here. And you notice no description here. Right? This is just showing you that we are at this context right now, we are in the right interface context of gig 01. And the operation I just copy paste there worked. Right, so enable IPv6 unicast router on R1, we did that. So let's come back here, see here. Now we're going to kind of create and configure sub-interface on R1, and I'm going to add IPv6 addresses one time. Right, so you'll ask yourself, okay, well, what are these sub-interfaces? So you'll have to do it as part of your plan. So I'm going to just open up the PDF, as opposed to opening up the say, hey, where's this sub-interfaces, right? Right, so you can look at each network. Let me see how far I can get. Civil management. Right, so it didn't have it as a router. So what I'm missing, a slide I'm missing here, is all the networks on the router interface, right? Now when we go into more routing, so this static routing, not much of an issue, one device. But with one device, you have multiple sub-interfaces. So instead of just two interfaces, you're going to have multiple. You'll see it here. See this R1 at the end here? So it's going to be gig 0/0.81. That's the sub-interface name. It's a number. Large number, you can go up to 4 billion. But for me, rule of thumb, I use the VLAN number to match the sub-interface. Now, there are cases where this may not help, and it may end up getting more complicated because you have duplicate VLAN. So this is what you could do. You devise a coding system where you use all the different integers to build it up. So you can actually say the first 4 integers values in that sub-interface code is meant for a certain site. And then after the last 2 values, last 3 digits maybe might be your VLAN number, or last 4 digits VLAN number, right? So you build that into your sub-interface, so it's easy to identify where it is, especially when you get more complicated. But this is sub-interface here, and we're going to see how to create it. The commands are there, so we just follow, right? So R1 there, look, R1 gig 0.1, 0/1, sorry, .111. You notice it's different from the gig 00, right? So it's a physical interface, but we put a sub-interface in that physical. Right now, there's only 2 physical interfaces on R1, and we basically putting multiple sub-interfaces on either one. So literally, R1 will have about 4 or 5 sub-interface matching ratios. So that was said, I didn't have a slide where R1 could have been in its own slide with configurations. And normally when you do that, it's to help match up what is here with that R1. So you could do a quick check and say, hey, is it configured correctly? Do a quick check. Are these guys in the same network? F7EA, colon 5, 521, 1, that should match on the R1 table, right? And it will vice versa. So yes, it's duplicate of information. But the thing about it is that it's going to help you double check and make sure it's correct. More information to update and change, but it's going to help it. Now, somebody say, okay, build a database, yeah, go ahead and do that. It'll take longer to build a database. Sometimes it's faster just duplicate the information, right? There's something called NoSQL code. So NoSQL is basically you're not doing as in the case of using giant cloud spreadsheets and stuff, where they just take the data as it is, duplicates and all, and then they apply their rules on it. and then like a filter and then generate the information you want. So it's not doing joining of tables, rationalizing, normalizing, none of those things happen in the database. So that's what they're doing. Just taking that to the next level. Right, so next step we look at our command file. That's these guys. And basically I'm just gonna do copy paste. So that's why this lab could end up being fast. Right, so that's what I like about copy paste, and it depends on the context. So this was happening here. I want to get back into enable configure terminal, and I type enable, and it threw an error because there's no enable at this context. I'm in interface context, right? If I do a configure terminal, it's going to throw. Alright, sorry. Throw an error here. If I do a config, it's kind of like showing you config register, right? Huh? Right, because I'm exactly. Because I'm already in configuration mode terminal and I'm in interface configuration mode, it's not going to allow me to do configure terminal. Now that's Cisco. Let's say Dell will allow you to do that. The Dell equipment, same Cisco commands, and that's why learning how to do what to do in the context. You change the hardware, you know what it is to do with certain things. The commands maybe change it different. So the Dell commands are literally almost copy paste. So I can actually type configure terminal at the Dell at this mode, and it will accept and continue going. Cisco would not. So unfortunately, I don't have any Dell. Technically, I could VPN on the wireless and show you now, but I would not do that because of time. But I can demonstrate, maybe, I don't know if I have time, maybe later on in the course, I could demonstrate with a VPN to a Dell's equipment I'm running and show you the same command I'm running in Cisco is the same command I'll run with Dell and get the results. Yeah, I could do it, yeah, but I'll say have time. So what's happening here, look, I type config and term, but now it's showing invalid hex value. This was different from my configure terminal up here and saying invalid input. What happened? So if it's showing something invalid hex value, something is up. So if I do config question mark, it's saying configure register. So in this global configuration mode, I can actually, there's something called configuration which is different from config terminal. Right? I'm not going to touch this. Configure register allows you to change some register values. You could go online as I think 2142 or something is one of the commands, hex value. You can do that to force the router to go into a RAM1 mode, which means that it's not going to load the configuration. It's going to go into RAM1 mode, not load password, nothing. So people use this as a way to actually bypass or break the device and get into privileged access without loading config. And then what they do, they dump the config off, and then they put their own config. So that's why that's physical access to the equipment. So that's why physical access, you don't want to, you want to lock away the equipment, because once you have physical access to equipment, you can actually override the boot up, put your stuff in there, take out the other configuration. What people can do is actually take that configuration and they put everything else, the passwords they don't have access to, but what they could do is put their own passwords in the equipment for now. And then they take that file, because the file is now in your possession. You can apply all your computational power to crack and break whatever is in there. So having access to the encrypted data is one step of trying to break the encryption, right? So if it's on the wire, that's why you use Wireshark, right? Wireshark will you get that encrypted data, and then you take that home or whatever, and then you can do try to break it with more powerful systems. And yeah, that's what I would have done. You would take a dump of all the data and then take it to a faster system and then apply brute force and break it. And you have time. So if you have like you have like a week, take the data off. Nobody knows that they have the data. You spend a whole month breaking it, and you come back a month later and then you infiltrate, right? So that's a cybersecurity thing you should look at. But this course, there's something that you could do. Anyhow, so we're going ahead. Now the thing about the next step is interface. So I'm going to copy and paste this. Now we already asked ourselves, okay, is it going to work or not? Well, something's broke here and took us out of global config mode, right? That's okay. because once you type and put in the interface, it's going to go into interface configuration mode one time. Now the thing is, because the interface is virtual, it didn't exist before. The moment we enter this value, gig 00.3, it's going to create the interface one time for you. So if it didn't exist before, it's going to create, and that's why it became up. Now because the interface is virtual, once it's physical, 00 is already up, the virtual is going to come up automatically. Some people may ask, hey, can I shut down the virtual at any point? Yes, you can shut down the virtual interface, and that will go down, the physical will remain up. Next question is, if you shut down the physical and a lot of virtual on it, will it shut down everything? Yes. If you shut down the physical interface with all the virtual interfaces or sub-interfaces on it, all sub-interfaces will shut down. So you have to be careful how to do that. Right, so that's one. We're going to do the encapsulation. I'm going to type it out here. Right, so just to show that the mode is there. Encapsulation dot, right? Now this happens more or less in the routers. You do this in the layer 3 switches or the ETA switches, the one that you'd see in that we have done in the assignment, which you wouldn't need to, but those are layer 3 switches. You may have to do encapsulation.1q. Right, in terms of to allow .1q is basically 802.1q is the protocol for trunking. Right, and after .1q question mark is had the VLAN ID. In this case, we're saying encapsulate.1q when we're dealing with VLAN tagging tree. And what is VLAN tree again, guys? That's our switch management network, right? So at the end of the day, we might even be physically interfacing to it. We might want to switch an interface. Right? And then because it's there, we're going to set an IP address. Right? And then we set an IPv6 address. Right, 12.0 here. Do a shutdown. Right, that is just the sub interface is being shut down. No shutdown, bring it back up. It didn't affect the physical. So this cool thing about it is that other sub interfaces will run while you shut down this sub. Right, so you ask stuff, okay, well, hey, did this work? Etc. etc. Well, one way to find out is to do two things. One, you can do show IP interface brief, IPv6 interface brief. And then two, you can also do show run. So let's do show run first. Oops, spelling it wrong. SH, right. So we're going to stop at gig where 00 interface, right? 00. All right, so let's stop here. So gig interface Ethernet 0/0. That's it. Remember we took off the IP address or v6. It's important. Look at this. It has a sub interface, so it associates this sub interface with the main interface. So all the sub interface will be there. If you have 100, it's going to be there. Sub interface, we did encapsulation. Look at that. We set an IPv4 and we set an IPv6 address. So yeah, this is what we want. You know, this is one thing. You can actually literally take this and copy it and paste it into our command document, right? And that is actually configuration for that interface at that point in time. Right, so another way is to do show IP int brief. Whole table, look at it. And this is what it looks like with the sub interface, right? And the IP address is set. If you want to do v6, so just remember I made a mistake. So always you can make a mistake. Where you say, hey, you set the IPv6 address, where is it? Where is it? And you're doing show IP interface brief, you're not seeing it. So you do a show IPv6 now, and there it is here. Right, sub interface, and yeah, you have the linked local address generated, and then the one that you have set the global unicast. Right, so I'm just going to follow and be setting all the IPv6 addresses, right? So you'll notice I'm setting subface and configuring one time, so I don't have to go back. So we set the IP. While we're there, we could actually do a shutdown or shut. That's good. Will make a difference. I can actually copy this whole block of text and paste and enter it, and it goes into there. If you're not so sure what's happening, you're right. What do you do? Right? You just do a show IPv6 interface, and look it's here. It's adding. Right, and I'm going to just copy and paste in a block of text in here, and we're going. So that's what this whole. You could use the command file to actually go through that. And now we're going to gigs 01. Right, notice I never had to come out of the exiting mode, right? Once it is one interface, some interface mode, you can go and select another interface. Now, let me show you one thing. It depends on the device. So Cisco, if you try to type interface and question mark, it does not fill out the rest of the command. So that's the problem when you go into these modes. That's Cisco. In Dell, if you do that, Dell switches will allow you to go and type question mark and see what else you can do. All right. If you're in sub-interface mode, a question mark is only what you can do in the sub-interface, but it's not telling you to come out. Right, but if you, that's why you should know the commands. If you know the commands, you can just type interface and get out of it, right? No problems. Takes you into that mode. Right? No errors. Right? Do we just do that? 01? Yeah. Yeah, okay. Right, and now we get to do the 1.1 or 1.11. Right? Paste that. Right, so the interface is configured. And the IP address is set. So this is the thing. I could do an end here. Oh, I didn't do an end in the command file, but I could have done that. And I exit all the way down there, and I could do show. Right, show IP interface brief, and there it is. All our sub interfaces here. Gig 01 as well, and we repeat it on the V6 side. 3.11.81, 1.5. That's these guys, right? So that covers these two guys. We did the sub interface and the IPv6. All this is on router 1. Right. Kind of halfway there. We're almost done. On the hour, I'll take a break, right? Right. So next step: ensure clients have correct gateway access. So this is a whole GUI thing, right? All these clients are GUI, and we're gonna have to use GUI. Right. So the next question is, okay, yeah, you have the GUI and everything. I'll make my save here. Oh yeah, when you make your changes, you could always, if you know, you could do just copy run or start or WR, right? Save your configs. Very important. Even saving package is good, but do it in the device, because as in case of GNS3, if it don't, it may or may not write that to your config, to the file, right, running, or startup config. Right, so next step, clients have current gateway access, so we will have to go through these guides and verify. And you ask yourself, okay, well, where is this information for gateway? You would have to find that in your PDF, right, or your documentation. Who's this? PC11, interface here, IP, mask. Link unicast, right? We set this first. Okay, so what I did not put. Right, so what I unfortunately did not put the default gateway in these tables. So let me update this now. That'll be PowerPoint. All right, now that'll take some time. We'll go through the diagram and we'll see. So what happens is that it's supposed to have mask. Yes, you're going to have a default gateway. Your default gateway is supposed to match more or less your router IP address here. In this case, it's 200, and it'll be a column called default gateway 200, and then you also have one. All right, that's what I did not do. It would be too much information to put on the table. Right, so you will have to use the router IP, and that's why I put the router IP. The table would have been too wide in PowerPoint, and I had to split, and it wouldn't look good. When you're doing tables in Word for your group project and stuff, you could actually put the page in landscape mode and use that. Now, this is the interesting thing about Word these days. Well, not Word, but most times I'm not going to print these documents. I'm actually going to mark them as is in Word. So what you could do is increase the page size, and Word allows up to A3. So you can set A3 landscape, and it's a bigger page. And if I print in, I could always print and shrink to fit. So it looks smaller text, but it will fit on like a letter size. Right? So set your page size to A3. Word does it up to A3. You could do custom size a little larger, but because of the printers and printer drivers and stuff, Word doesn't really go larger than that. If you want to go bigger, then it's like Microsoft Publisher, which they're going to deprecate next year. They're going to kill that next year. So, or PowerPoint might have different page sizes, or PDF. When you do PDFs, the printed PDF will go a larger size. But Word by itself, Excel could do large sheets as well. I have seen like 108-inch, really large page. Excel could print that page. So when you're doing Word, you could go A3, and that'll say it looks good. The diagrams look bigger. It formats. It doesn't resize. Problematic. And A3 closer to the 1080p screen resolutions as well. So if you take a browser and you take a screenshot of the page, and you take that and paste it into a Word A3 size, the kind of size looks good. And when you view A3 in full screen mode and 1080p, it looks like a browser web page. So A3 is kind of like matching what the web browsers use. And you can zoom in and stuff. So that was said, you don't stick with letter. You don't have to stick with letter. Letter size or even legal, you can go A3 size. Right, for the purpose of this, I could have gone a smaller table and font, but will be problematic. So that's why I do not put the gateway. So gateway, remember, is always look at the router, so we set this up. So let's make sure our PC IPs are set and our gateway is set. So we're going to go there. Right, so this is popping up on my screen. I'm going desktop. Right. Luckily for us, it's already configured. I think I may have configured most of these, but you guys do a double check. So what's happening here? We double check with your cable. IPv4 address, yep, it's checked. Mask is good. Default gateway is matching to this guy right down here, which is good. Now, what's new? Right, is DNS server. That's not set. I mean, it's not in the table. I have preset that because we're not touching DNS in this lab, so it's already there. Then we go into IPv6 address. Right, this is the IPv6 address. Look at it here, 11. You have link local. Now, link local may or may not match up what I have here, but I think I did create it and copied it here. Default gateway. Right, see default gateway set as well. It's a new router, and again, look at that IPv6 DNS server is also set. Right, so not part of this scope. It's not scope of the lab, but it's there. So this PC is good. Right, so our next part of it before we continue. Right, so clients have correct gateway address. Now the thing is, the moment you set a PC IP address here, technically, and we have already set the router IP, right? Trunk ports are already done, so we can always double check that later. We assume trunk ports are done. Remember, we just doing into VLAN IPv6, setting IPv6 into VLAN router. We're not touching setting VLANs. That should have already been done. I did not state that there, but it's something that we could double check and see, right? So if it's done well, PC11. Once you set the IP, it's supposed to ping the interface, sub-interface of router 1. That PC11 has to jump through 2 sets of switches. Just assuming the switches have the VLAN set up on the trunks. So we can start with it now and see what happens. Right, open PC desktop mode. I'm going to just copy its own IP address. Right, the main reason I'm doing this is to make sure that my my TCP stack is working, right? So the IPv6 is working. Next step, I'm just going to ping the route interface. Just look at it. It's just the ::1. Right. So again, timeout. Work now. Who knows? So if you get 4 timeouts, then we may have to do some more work. Right, so again, all timeouts. So now we have to test and see these switches have these trunks, and we have to work with it. So we have to do some troubleshooting. We do real time. Let's see. Ping. Right, step. I'm doing all protocols. This shouldn't be a big problem, right? So it's going through all switches, broadcast going out here, broadcast going all over. Look at that, broadcast back and forth to span tree and stuff. You see what happened there? This has been a loop. The span tree protocol, don't worry about that. Right, so just sending span tree updates, right? This one had all protocols. Right. Right, it's a layer 2. Remember doing ping? There's some updates happening here. Must factory. Alright, so technically I should get our first time out. No, it didn't happen yet. Didn't get time out yet. But anyhow, so now we'll look at VLAN. I will deal with the other pieces afterwards, but let me just see how this VLAN is working, right? So we have to deal with some switch stuff. Right, what's it? 81? The student, right? Active, FA1, right? So the VLAN is there. So now we have to check this trunk. One through 81, right? VLAN's allowed. Management, so we're looking good here. Right, we gotta go to the next switch now. Yeah, VLAN 81 is there. Right. All the trunk interfaces here. And Gig 01 and all these guys are there. So the next question is asked, well, okay, well, which is the trunk interface going to your router? So you may be thinking, oh, looks looking good and everything looking good. You have your trunk interfaces, but you have to plan it out, right? You have to know. And that's why there was another Excel sheet I had called local connections. So basically what it's saying is that they're mapping out all the interfaces on a switch, and you're going to see what it is. Is it access? Is it a trunk port? And you work from there. And then based on the network design, you're supposed to have a layout pointing to the different devices. Now this is the thing. Who is connecting to our which port from the switch is connected to the interface in R1? We could look at the diagram, and the diagram should be labeled Gig 01, which is good. And we just look at see who's popping up on the other side, right? FA0/10. That's this guy here. So we had to know, okay, is FA0/10 a trunk port? Right, this is switch 12. Right, 10 is not here. What is 10? 10 was listed somewhere here. Ten is not even in a black hole. Oh, look at this. 10 is actually faster than 10 is in a default. This should have gone in a black hole VLAN, but it's not. I think it's by design. Well, not by design, it's like a mistake. This should have gone in default. But what happened was by design, because I may have placed it in a trunk, and then I would have removed off the trunk, and it went to default VLAN. These two guys should not be there. You're going to have traffic in here as default VLAN. You don't want VLAN traffic 1 being accessed anywhere else. So we should take them out. But that's 1. But 2, 10 is there. I mean, it's not a trunk. Right? So how will we be able to fix this? Right? 10, and then right, we do a shut, shut over mode trunk, shut, no shut. Right, and if we could do show run just to see what the interface looks like. 9, 10, look him here. And he's in an up mode, right? Right. Show interface trunk. We'll wait a while. This should pantry, not pantry, but VLAN stuff supposed to come out here. So this is supposed to show. We didn't tell it, we didn't prune it or anything like that. It's not pruned, so it's supposed to show something, right? There, 10, look at that. Start pick up VLANs being broadcast. So we now fix the last thing here between these two. So let's see if PC1 can still do what it has to, right? There we go, reply. Nobody's seeing it well from the lab so much, but it's on the video camera and the screen recording, right? So yes, we're getting a reply. We're getting a reply, which is what was happening. We have just kind of fixed that issue. So you see what we just did here with that switch? Took that coordinate trunk. Every single sub-interface information, VLAN traffic is now going to go along that trunk. So that kind of fixed the problem for every other PCI as we go along the way. We may have to do the same thing for switch 21, and when we reach there, we'll test that out. Right? So let's get all the other switches sorted. So once you set all these IPs as we go along, and that's why I always ping your default gateway. So once you set an IP, you ping a default gateway, and we fix those things along the way. That's layer 2, layer 1. Layer 1 was good, cable is good. The layer 2 problem is what we had, which was VLAN, and we had to fix the trunk. Trunk is part of layer 2, so we had to fix layer 2 in order to get layer 3 to work. Right, next step. So we still have to do more PCs. We're going to do all these pieces in this VLAN, PC12. Now, technically, once we fix all of this, and we fix all the trunks, that means all these pieces can ping to the default gateway, means that they can then get traffic out. So PC11, PC12, check them out. Right, he's good. And you have IPs as set, and we can start pinging. Ping itself should be okay. Ping the router, and it's working. Alright, so we kind of fix this problem for the other PC too. So this both PCs can ping. So we're going ahead. 12, 13, 14. Let's see how these guys look. 11, 12, 13. And he's set. Do a quick check. Ping itself, we're good. Ping the router, yeah, we're good. And then 14, there's 14. Itself, it's good. Clean the gateway, it's good. Right. So we just finished all these guys and double checked they're all working. They can ping the gateway. So that's what you do when you're setting up, especially with your routers. You're making sure your router can ping the router on the other side. When you set up a PC, make sure you can ping the default gateway. This default gateway is your sub interface that you have just set up. That's right. Shadow network PCs, 20s, all the 20s. Right, now I didn't bother too much on the IPv4 checks, but if you want now, then you can do the IPv4 check. Not normally supposed to do both, but for essence of time, I will let's see what time is it. Yeah, I'm gonna do. Right, so essence of time, I want to just check v6 as a purpose. 21, 20, 24, 25. Let's check these guys out. Right, IPs are set, we're good. We're going to run the ping again. Ping that. While that's happening, let me just check something. Make sure the gateway is done right. Right? Colon 1, right? Make it easier for us. Alright, we're getting a reply. Alright, which is good. Reply means PC21 to switch that from 21, switch 21 to R1 is most likely a trunk port. Packet is going across and coming back. And it's matching up with the subinterface dot, I think it's 111. Okay, not so sure. Always go back and check the table what you created, right? 21, 22, 23, 24, 25. So let's do this quick. 21 to 22. Let's switch 22. I mean, piece 22. There it is. Sorry. Ping itself is good. Ping the router, we're good, right? 22, 23. Right. So someone say, hey, you know, maybe you could do a shortcut and just keep pasting the same IP over and over. Don't have to worry about copy pasting it from the config, right? Sometimes, and that's the reason why I copy paste from here and paste it and test it, is that in event that this information is incorrect, as in I could ping itself, but if I cannot ping the gateway, then I have to verify that IP address I set there is correct or not, right? So I may not copy from the table, I copy from what is already set and I apply my test on what is already set and not use the table. Table I then back use as a reference. Double check. So you see there's a lot of table captured information. If your PC have it, you could double check or you could do a diagnostics one time. Save on time when you do this. And you're good. So 23, PC 24, we should be fine with 24 as well. Right, you can ping itself and the route. And then 25, where's 25? All the way up here. Right, 25 can ping itself, yeah, but can't ping the router. Yes, it can. Where do you think that traffic going? I'll tell you where this traffic is going. Anybody can make a guess where this traffic is flowing from 25 to R1 interface? Think about it. Where do you think this traffic going? Zoom out a bit, make it easy. Not easy. Where do you think this traffic is flowing? It's coming from PC down here, lower left. And it has to come on the R1 interface here. Right, 11 to 12, right, go ahead.
And then with the R1.
Then you go straight to R1? And which interface on R1? Am I pinging the gateway? Well, remember 00 is no IP on it, right? No IPv6. We took that out. If you look at this diagram, you're not seeing it, any IP. So it's going to be gig 0. Yes, the interface, but it's going to have to ping a sub interface, right? So which sub interface? So ping.
1.1.
Sub-interface gig 1.1? Well, that'd be gig 0/1.1, right? So gig 1.1 doesn't exist. There's no 1.1.
No, 0.11.
Oh, 0.11?
Yeah.
Alright, 0.11. Remember we had to verify who this network is, right? Might be, who knows? 0.11. Zero 0.11 is the accounts network. It's on zero. It is a different IP. So what's supposed to be pinging is 0.1. 0.1.111. 3 ones. Right. So you have 11 there, and then you have 111. Right. So you have those two interfaces. Okay. So we get in there. Go ahead. What else? How it's going? Where is that interface, sub-interface located? Physically. Nobody? Physical interface for the gig 0/1.111. Right, that's the gig 01 interface, right? Gig 01 on this router is on the right hand side of this router. So this is where the gateway is attached, and you can see I put labels here. These are labels here. I have to put labels to tell you which sub interfaces are. Packager wouldn't do that, so I have to put it in. So gig 0/1.111, that's on that sub interface.
So you have to go up to the core one.
Alright.
Go back down to the
It has to go up to the cores, come around to the switch 21, and then come back on that interface. Because there's no way broadcast wise it can get to that interface if it comes back on the left hand gig 00. So let's packet tracer simulation mode that, right? Number 25. Alright, let's clear out all these filters. I don't want all these excessive filters. ICMP V6 we want, right? Alright, let's set this guy up. Good. And we're going. Right, this is normal. I just said it goes to the cores. Yeah, that's what it did. Went up to the core router, went around, come back to that switch, and then goes back to the R1 interface, right? So it actually followed here, so it did that. Come back, and it went all the way down there. Right? Some people might say, hey, you know, it's inefficient, Yes, it is. It's all a matter of how this R1 interface was configured, where it was. That means this R1 where it is located. The interfaces should not have been there. That should have gone up to the core, where it hits a core and it just comes back down. The core is high bandwidth. Look at how much at the channels there. It would not matter which interface in the R1 is to the core. It will just do one hop and then bandwidth coming down to the interface. So this should have gone up to the core. These two R1 interfaces, but I just did it to the switch to demonstrate because the cores didn't exist before. We added it later. So now we'll have to modify some of the design. But either way, so PC25 is good to go. Not this one. Right? So I went back to real time, right? So 25, let's finish off the others. We did shadow, we're gonna do accounts, silver. So let's get these two guys sorted out and then we'll take a break. Right, 31, 32, 33. Who is 31? 31, all these are silvers, right? So 31 is right. 31 is here. Counts. I don't know why it embedded there, chef. I don't know why it not Packager wouldn't allow me to do much overlays. That's the problem. Put a square and a square then. Is it matching up? Right. 66, that's what it is. And we go and do a ping. Ping itself should be fine. Good. And then we ping the default gateway now. We think the default gateway is 1, but check your table. It's not. It's actually 65. Right? So I intentionally change it up to 65 because it's matching the IPv4 layout. So I kind of did this to say, hey, look, IPv4 is have this set up. Your IPv6 can closely match your IPv4 layout. You could, heck, you could even put literally IPv6 address could look like 192.168.11 or whatever in IPv6. You could do that as well. But of course, remember it's hex, or it doesn't all that hex values, right? So it'll look like IPv4, but it's not. So it's matching up, and we just pinging 65. We're good here. Right, let's move it to the next PC. 32. Desktop, command prompt, ping 65 gateway, we're good. And then ping T33, and then we'll do the servers. 68, we're good. Command prompt, ping. Right, we're good. 65 is our default, we're good. Getting a response. Right, that covers these guys. And now we're looking at the server network, which is just 2. Find these servers. 21, 11 and 21, right? So 11 is here. Desktop IP. Right, 34. And the gateway is what, 1? Total. Let's find out. Gateway is not 1. Set up to 33. Right? Reply. Good. Servers are pinging the gateway. 21. Right. Look at that. 21 doesn't have anything. So this might be the only one you have to configure. So that's why we checked the order. If you did assume that this server didn't have any, this server is configured, and we have to fix this. So break taking a little longer than get it there. Yeah. Look like break will be a little later. Right. So 21. P4 address. Let's fix this up. Simple. Mask. Go. That's not. Oh, bit of crash. I need to save this. Save that for a second. Right. Okay, I'm going to put the mask first. Because it said there's an overlap happening, right? So let me just do that and fix this up. Oh, sorry. Wrong Ethernet. Okay. Yes, what's configured? I just remember server has 2 interfaces on this. There it is. So I was going to make a mistake. Windows will pop up and tell you that it's an overlap, right? So what I got was that it's saying, hey, the IP address I'm setting on this interface is overlapping with another IP. So I take it as mask. So look at me as an admin, just doing and checking it, add it in. Put the mask in first, thinking that is the problem. Put the IP again, it's saying, hey, it's overlapping. So if I had the mask and I put in the IP and it's still overlapping, there's a high chance that that might be already entered somewhere. Right? There's a high chance. So I go to gigabit 1, well, lo and behold, it's there. Right? Now I could have cut short all of that. Look, I didn't even check gigabit 1. And that's why you document your interfaces here. right? It verified, it double checked, and it's there. So even though I make a mistake, I was going to make more problems, but when I realized, fix it one time, right? So this is server 21. So he's looking good. Command prompt. I think it's 33 is our right. 33 is our gateway. I'm good. Right. So all IPs are checked. And now we're going to set up management network and set the IPs on this, and we'll do that after the break. Right, so we're going to take a 10-minute break, and we will resume after. Let me just bring up my notepad. 10-minute break. What time is it? 1:10. Resume at 1:20. Alright folks, we are back. Keep this streaming up from window. Alright. Alright. So we have finished the point where so we're done here. So the next step is add management VLAN to switch, configure the management on devices, times ping in between networks. So technically speaking, guys, as you know, we can actually test pinging. We can actually reach here right now. Number 10, we can go there right now. Why? Because the router is going to do the work of routing. It has all the, and when we go to the router, we'll do it. And actually, let me jump straight to that, and then we'll go back. And we will continue. We will continue. So we're going to here. We're going to go to router. And what was the command? Show IP route. Just resize this a bit so it looks nicer. Right. So this router is supposed to have knowledge of all these networks. The only thing it doesn't have access of is, well, we just put the management. The black hole doesn't route, so it's not there at all. So the management is .3. So it's there, the router sees it. So it's actually going to take traffic coming one side and then put pass out the other. So that's one. But let's see, is it sure IPv6 route is doing the job? Well, yes, it is. We also have IPv6 routes. See, look at that, /64. Look at next one, 5E05/6. So all those connected already there, right? Because we set the IPv6 addresses on the interface, now I told you it's going to go onto the routing table. If it's on the routing table, it'll do its best to route. Remember, we didn't know default gateways here yet, right? Fine, no, look at this. No default. We didn't set one, we don't need one. Not in this lab. So the router is supposed to do the work, and let's find out. So we could always pick up on a, let's go to one of this table. Let's pick a server IP, one of these guys here. 35, right? We go here. And then we pick a PC, any PC. 11. Ping. Paste that server IP here. And let's see what happens. Work? We don't know. Right, so the chance is not working. We have to check this, what's going on. Then technically it's supposed to work, right? Default gateway knows where to send traffic. So now we just do a diagnostics. We could do that just now. So let's go back here. 33. Let's try 33. Right. So we did it. So this is what happened. I could not ping the 34. All right. Now I'm pinging 34. So there's something wrong here. So that's why you do more than one thing. Look, 35. So I just changed the values of the so look what happened there. I could not have gotten through 35, which is a server. So I said, okay, let's ping the gateway 33, and that worked. I said, okay, if the gateway works, right, and let's do the gateway ping, and I'll show you why. Not even 35, let's do 34. Right, so I'm going to go simulation mode, and we have there, and we start the protocol ping. Right, this is PC here, and it's going to go to the server down here, 34, right? So 34 is 30. Yeah, this guy. So it's going to come here. But it's where it's going to go. It has to go router first, right? So look at that. Go to the switch, skips, goes to this direct route interface. And you just have to understand what a VLAN is, eh? VLAN 5 is supposed to be that server VLAN. So it's going to have to come out of the interface, jump, go all the way out there, come back to the switch, and then to the server and back out, right? And that's the response, so that works. So we work in here. So we want to know why in the world 35 is not working. So we'll break that, we'll go to simulation. You realize you may not have simulation mode. You gotta use Wireshark and stuff. So let's see what happens. Sends it, sends it, sends it. The router sends it out. 35 is where? Down here. We're good. It picks it up. And now it's not signed. It dropped. It never returned. Request timeout. It dropped. So the question is, does server 21 know how to send that packet back, right, real time? So let's check it out. Pass it to 1. Does it know how to send the packet back? Well, we have a default gateway, but take a look at it. There's a bug. Default gateway is not 1, it was 1, but it was supposed to be 33. And that is where your IP address table is coming, right? Look at that. It's not 1, it was 1 before. Yeah, look, it's doing some buggy thing here. Alright, that's fine. 33, right. So pinging is one thing, but was the default gateway set? No. So let's go back to the PC now and rerun the ping. And now we're getting our response. Essentially, the PCs here can ping these servers and vice versa with the default gateway. So we just had all diagnostics and we had all troubleshooting to do. Gateways weren't set on this PC server 21. So we did not go through the full process double checking that it had the gateway set, which was this IP here. Right? We did that, didn't happen. So just have some caveats. When we try to do shortcuts, we miss out things. That's why you have your checklist. Right, so now management network. Where are we? Management VLAN to switches, and we'll work from here and let's see. We'll look at our switches. There's 1, 2, I think the core is supposed to be there. We'll see what happens. And all the config is there, right? So I'm going to hit the configs. Save on time, right? A lot of files open here. This is our config. Look at this. Switch level and add management VLAN. Look at this. I just put this thing. We'll check this out, right? Call will work with it. We'll see. Right, I'm actually going to copy paste. This is new. IP default gateway. Right, so remember we talked about port 0 and all these things? That was routing. How do we do default gateways on a switch? Because it doesn't route, right? This is where IP default gateway comes in. So the main purpose of this is not for your switch to be a router. The main purpose of this is to say, okay, if my switch needs to send traffic for management purposes to our device on the other side, so my PC, which is on a management PC somewhere else, different network, can connect to this switch, and the traffic could come back through a router back to me. That's what this IP default gateway will end up doing. Any other traffic, management traffic, will go through this. There's only one, as you can see. You cannot set up more than one IP default gateway on a switch. There's only one you can set. And now we go into VLAN tree. Name. Well, I call it management here, but technically you're supposed to call it device management because you can actually have a management network in an enterprise, right? So you can actually have management. So you could call it, should call it device dash management or device management. So let me just rename it a bit and it's called device, right? This is local on the switch, that's an issue. Right. So now look what we're doing. We're setting an IP address on it. So we start to set an IP interface VLAN tree. Now because the interface didn't exist and we type it, it's on first a virtual interface and it's on VLAN tree and it sets it up. And now we can set an IPv4 address. Paste this thing. Right. So I did a note to myself, IPv6 error. Look at this, I could copy paste this thing. That's what I like about putting comments. This is how you do comments in a text file. You put the exclamation mark, which is a kind of like a comment, space. I put space to add more what we call delimiters and markers to know where it is in the map. When you put, and easy to find this. Search and replace. And I put a note here saying it's not sorted out. So there, right? Because if I do IPv6 address, right, it's not supported on the switch. Right, so I cannot go forward with this. In this case, GNS3 can, because of the version of the iOS and stuff can handle it. It's at a switch router, at a switch too, so you didn't use that. So I'm not. So technically, we can't do IPv6 management network in this packet tracer. Limited. We're limited right now. Right. If we do, there's no IPv6. If we do a config T. Right, there's no IPv6. There's IP, but there's no IPv6. Right? And I'm doing a show version just to show you what version of the iOS we're looking at. Look at this guy. 12.2. 2005. So this is packet tracer team did this. So the iOS is too old in Cisco. This Cisco packet tracer, and it could be because of the switch model I use, right? So if I drag a different switch model, it might have supported it, but that'll be a whole redesign in this lab, right? It's a 2960. That's this guy. This should have worked, but let's do a 2950. Yeah, I just trained up on a fun kit switcher. Right, so that's why I didn't like to use these. It's not standard, they're too old. Yeah, it's good for you. This is a weird version. We'll check the version. It's also 12 look like, so it might do IPv6 either. Right, Cisco iOS 12, still on 5. Some do. Right, so this is not going to do the job either. So these switches are too old in terms of packet tracer, so we have to look at 3560, which is a layer 3 switch, which I didn't want to go to that point. So I'm going to leave this guy here. No, I'm going to delete him, I don't need it. Oh, where is it? I don't want it. Save again, because I want to kill it. Right, so we're moving ahead. So we're going to have some errors. Shut down, and that's fine. Nope, Control Shift 6. Let's go back here. I can literally copy paste this over and it will execute everything over, which is cool. And I did the end command here, and look, it took me out. Show VLAN, show interface trunk, paste that in. Went way up. Who we did? Tree. Look, he's here. No interface is set. VLAN tree is going to learn it. It's going to go out there, right? And how we get, what I did not show was something called show IP in free. And look at this, VLAN 1, VLAN 3, sorry, it's added here. And it's an up state, right? So we've got this set up. Right, now this had a setup trunk to R1. We did it already as diagnostics, right? We did it already. It's set up there because that's how all the configs you need for the lab for this switch. So that's why it was there, but we ended up doing it manually to fix it. So I could copy paste this and it would fix. Look, we removed this one. I could copy paste this right now and apply all the configs to R1 for switch 12, but I will leave it. If you guys want to do it, you guys could change it anyway. But I'm going to add my management VLAN, which is what I want to do. Not 12, 12, 11, 12, 12. Right, perfect. Copy it, default gateway, everything remains the same, paste that. See, look at me, on regular mode, I actually could do the enable everything command, one shot, did everything I want. Right, I'm going to copy this, I don't want the error to come up, right? Paste that. Change the up, I can copy this and show the error just to see. Right, error here, that's fine. Shut down end. Right, take us all the way out. Show VLAN, interface trunk. VLAN tree is there. You realize that I did not prune this 999, so it's going to be seen on the trunk, but the commands are there to do it, but I didn't put it in this case. Tree is there, right? Show IP interface brief to really see if the VLAN tree had it here. So, right, so this interface and this VLAN. Right, so it asks up, hey, does VLAN tree have this interface in the entire network? No, this is specific to that switch. Now, because we have set it up, this is what we can do. I can actually ping 192.168.3.12. Oops. Wrong one. 12. Right, I can ping itself. That's how it works. But I can ping 11. Well. Right, there we go. So you see what's happening here? Right now I have two switches, 11 and 12, set up. Interfaces are on it, no physical interface. But because of this trunk going across, that's physical interface, that traffic is flowing. So switch 11 can ping switch 12 because they're on the same, they're on that same VLAN, because that tagging traffic is going across. And I could ping 11 to 12, right? So once you get that concept in, once you start to add trunks along the way, and that trunk is tagging that VLAN tree, wherever another switch is connected and it has that VLAN tree, and you have an IP address, you can ping that guy across, right? Now this is the thing, because it's VLAN tree, it's not, it's going to route on the router, but because it's everybody on the same layer 2, there's no routing happening, they'll just span across the network, and we'll see just now. So let me just fix the other switches, and go from here. 13, same thing. Is 13. All the way down here? Yeah. I've been there for 15. That's okay. That's why I label the switches here as well in my config, because they don't know from it what it is from here. Right, interface, and I could copy this whole thing all the way down to end, and do everything I want. And that's why I like about these commands. So it's not like a running config. A running config is just, you could end up putting unnecessary information. But this command file that you create with your equipment, if your equipment config lost, this is enough to come build back what you need to do, trunk everything, right? And that's what for your assignment I expect, and then I expect that to be do project as well. So you have all the commands ready. So if somebody breaks something, go back to the file and fix it. Pretty good, because you can put this in version control like Git and stuff.
Yeah.
So people can make changes, review it, if it's good, okay, then you pull out the raw, paste it back, go ahead. Go back to the older version if you want. Right. So we do show VLAN. What am I doing? Right. Show VLAN, show interface trunk. Right, 1 and 3, that's good. 11, that's that network. And if you do a ping, 168.3.11. Right, get success, good. Remember Max had to learn it, so they cannot ping on timeout, so it's pinging. Switch 21, let's go. Right hand side, and then the codes, right? So it's 1, 2, 3, 4 more devices. Diagnostics test after that, and then I think we should be good. We'll be done. I can literally copy all of this, even all the comments. Remember, these are comments. Hold on. 21 had a trunk, but it was working. Yeah, trunk is there, but it doesn't matter. So this is just the trunk. So I did all of these commands. Right, so it set up all the trunk stuff. I could paste that, not an issue. Execute everything there. Now, what one of colleague engineers would say is that, yeah, you do all of that. Maybe you should just to be safe, go back and check and see if you've seen any errors, right? So look, there's some errors here, right? So you could always go back and double check and see why these errors are there. Looking at after that, you see no more errors after that. Many commands were good. Show VLAN and put that, right? Add management VLAN. I'm literally copying all of this, all the way down here. Heck, let's do the show as well, right? So literally the whole thing. I could copy this whole thing. Let's wait, factories are doing some stuff. Alright. It did a show VLAN, that's fine. But we want to do, what we do is a show IP interface brief. Look, management is there. VLAN 3 is there, 21. But if we want to do pin 168.3.11, right? So we're doing this just to make sure. Right. So it's working. Of course I didn't see it, but now I'm doing it. 22. I have plenty factors of Windows open right now, right? So that's why it's slowing down a bit. So I'm literally gonna copy everything here. One big block. Well, actually, not even a trunk, so everything's sorted. So it's one big block. Peace. Right, I'm sure it's going to work. We're going to just ping. Right, ping is working. Do it again just to make sure. Right, we hit the cores. Right. Do I have SDM preferred? I think yeah. Right, so this, not even SDM, so dual. So normally it's supposed to be dual, there's no dual here. So this is a command in the cores that you can do SDM, you can read about it later. To set enable IPv1 v6. So instead of unicast routing, you have this for the switches. Right, so these cores up here, as these guys up here, these are layer 3, but they still have to do some to allow boot. Right, so I think the unicast is already there, but just to make sure. 6, get out there. Supposed to be here, let's see. But that's okay. Show version, you'll see something with this. The Cisco iOS, it's going to be a much more modern. Ah, 12.2 no. Yeah, 12.2. Okay, this one supports IPv6. The other one was older. This one is up to 2007, I think. While the other was 2005. So there's some difference with other. So let me just right, so before I do all SDM preferred, so you guys will know about it. Just know some Googling. So this could actually do routing IPv4 v6, and you do VLAN bias. Well, you don't have to, you can do routing bias, but we'll focus VLAN bias, right? You did it right, but it says reload, but I'm gonna do reload. We should be fine with this. Sure. Right, it's good. We're right here. Now, I suspect the cores already have this configured. So I'll go to the core 1 and we're going to verify, right? So before even configuring. So we'll show you how we're going to do this. So this core is there. Right, how we do it, we could do different things. One, show IP interface brief, and look at it, VLAN 3 is there, so it's already configured. One way to tell as well, we ping 3.11, right? And that's the fastest way. When you start pinging IPs and get internet connectivity, it's working. Right, there you go, success. Good. So we don't have to do anything. Core is done. And that's the whole configuration here. So let me go back to the slide. Right, so we finished this. Managing IPv6 only in the cores. Right, where we didn't have to do it here. Cores, right? test ping in between networks, so then we're going to look at the core with IPv6 and then the others, right? So, and we don't have to even bother about, but we could use our table here to do it. And if we can ping v6, it can ping from anywhere, right? And how you can do it, you know that why? Because, well, it's supposed to. Let's see.
I think you have to do /64.
Backslash
64.
64, maybe.
Mine was getting that.
Or when you're doing that,
Yeah. Everybody 64. Then get what's time on.
alright, let's try ping the default. Alright, so this works. So you did. So wait, if you do the C0/64, that'll work.
Yeah, we got mine. When I was a GNS tree.
That's GNS tree. That's different.
Yeah.
Yeah. Might move a packet tracer. Get timeout. So the problem is that if we do a packet tracer trace, we might see that the core may not. For these things, IPv6 kind of problematic with the. Right, so there's no IPv6 default gateway. Let's just see if we can fix that, right? Right. Right. So what happened in here? Right. So there's no. So it gets all complicated. So you can add this here because it's a layer 3 switch. Can do routing. So there's no IPv6 default gateway here. We'll have to do our IPv6 and default route out to that network, right? So let's do an IPv6. Well, I'm not going to go through the whole IPv6 routing. That'll be more for your group project and stuff that you'll be doing, not in this. Well, actually, I could, but do I have it? 5 minutes till now. Don't have time. All right. So write that out. Okay, good. So, yeah, we want to spend that'll be troubleshooting. We're adding an actual IPv6 and stuff in there. So this is the thing. This PC can ping 192.168.3.21. This is IPv4. So remember, we were having trouble getting the v6 on the management, right? So let's try the v4. Right, there you go. So what's happening here is that this PC is not even connected on the VLAN tree, but because of that router R1, and he has a sub-interface configured, PC is going to go to R1, send the default gateway, R1 saying, hey, I know where to get it, and it's going to send it out, right? So what's happening here, this whole network, all these switches are all on the same VLAN, right? And they're all accessible to one another. So, and this is the next thing, they all want help. So technically what you call that design, that management is more like that design is more like a flat network, they call it, because that VLAN is spanning right across the enterprise. And you may not want that because you want the broadcast to stop somewhere with the router. So ideally, that is where other groups 4 and 5 or 3 and 4, where you are actually going to, that design is where you have your cores, but you have breakout to the distribution to layers, and that layers are where your router is going to be. So you're going to break up your route into different routing net sides, different subnets, and those switches are going to use dynamic routing to make sure the traffic could flow between them. Right? The one network could reach the other network through that dynamic routing. But it's not a flat network anymore. You're going to have a tree-tiered, a true tree-tiered network. And that's what's going to happen. So you see that this example here where we have all those cores on top, that's not going to happen anymore. You're going to put distribution below. and routing is going through those devices, then touch the core and then come back out if it has to. If not, the routers could come into one and send traffic between them if they need to. Right, so the distribution is more for like longer links, different parts of the campus. So that's what this is here. Right, so test between networks, we're good here, except the V6 part, we're kind of problematic with the V6. Right, so we didn't set the, because the cores are actually then routers, layer 3s, we can actually add routes, little IPv6 routes on it to tell it, hey, to get to the router out there, this is where to go, which interface, and then you can, packets can go to and from via IPv6. But there's only two cores, the two cores. But we don't really worry about that so much. If you guys want to do that, you guys can check that out and test out the routing later and set it up, right? So that's the end. Let me see, 10. Right, so we're done here. We're done here with the command file, and this is what we're good. We're completely at 12, 15. You guys could check this out for your subnet calculators. Do more the calculators and stuff, nothing new. And that's the end of this lab. Alright guys, I think we're done. Just let you know, no class on Monday, of course, public holiday. Right, so our next class will be on Thursday. I guess I'll put out an announcement later today, tomorrow, just to let you know, just in case. Right, so I'll see you guys on Tuesday, and we'll prep for Saturday for exam, right, or mock test. Happy Diwali, Shubh Diwali, and yeah, see you guys on Tuesday. Alright, don't forget the attendance for those in class, and I'll pull your attendance from Zoom online.